Welcome to CETV on Cloud on Air, live webinars from Google Cloud. We're hosting webinars every Tuesday. My name is Jay Smith. I'm a customer engineer here at Google, and with me today is Dave Payne with Elastifile. And you can ask questions anytime on the platform, and we have Googlers on standby to answer them. So let's get started. Dave, tell us a little bit about yourself.
Yeah, thanks, Jay. Good to be back. It's been a few months since I was last on CETV with you.
All right, welcome back.
Yeah, we've been really busy in the last several months, and so I've got a lot of things I'm excited to catch everybody up on if you didn't see the first one. So real quick about me, Dave Payne. I'm the VP of Alliances with Elastifile, where we build a scale-out NAS platform that runs in cloud, kind of bridges the gap between enterprise IT and cloud applications. And a really nice fit there, so I'll get into a lot of the details of that as we get going today.
Good. All right, well, I guess we should just jump right into it then.
Let's do it. So yeah, jumping right in from there, the first thing I'd like to talk about is this idea that cloud is winning, right? This concept that we've seen cloud really start progressing and gaining momentum over the last few years. To me, I don't know, you work at Google, but yeah. It's kind of the de facto approach these days is I see most enterprise shops are shifting from we're trying out cloud to we now have a cloud strategy, if not a cloud first strategy.
Right, yeah. I remember when I was getting into tech, the early or late 2000s, and cloud was still relatively new, and enterprises wanted to stay away from it because security reasons, or they all thought they could do it better in-house. But now things have definitely changed.
Yeah, there's still reasons I think for people to work on-prem and in other places, but by and large, the default approach I think is becoming cloud first, right? Which is awesome because there's amazing things that are accessible in cloud, but it also creates a problem since there's trillions of dollars of investment in on-prem technology that doesn't have quite a nice home in cloud quite yet. And so I think what happens is, those that are winning are the ones that are figuring out how to adopt cloud technologies into their strategies right away. So like as kind of shown on screen, startups, it's really easy. You're starting from net new.
Yep.
You can adopt microservices and cloud APIs and just develop from scratch. But those that tend to be falling behind are either those that are kind of holed up in their antiquated strategies, or right, especially in the infrastructure side, where I think the cloud is really dominated and making it simple and easy and kind of on demand. If you're building data centers and servers and storage, you better be a hyperscaler in order to even get the economics to make sense.
Yep.
Right.
Yep. Just makes sense to have somebody else do it all rather than you try to build data centers around the world.
Yeah, exactly. So I think there's room for everybody. It's not just the startups and the new companies that are succeeding in cloud, but what we're seeing out in the field is we work every day with enterprises, is very large organizations that have been around for decades, if not centuries, are now going cloud first as well, right? And it's pretty exciting.
Yeah.
But what we're finding is as they get past their initial movements into cloud, there's a whole host of applications out there that run into roadblocks. I call them second order problems. The first order problem was, are we going to cloud and which one are we going to pick? And people are starting to settle in on that one. But once that decision has been made, the C-levels say that's our strategy, we're moving forward, then you run into second order problems. Like now that we've decided and we're moving forward, how do I get my existing applications to work?
Right.
How do I refactor things? There's a series of problems to run into. And so in storage, since storage, as much as I've been trying to run away from storage my whole career, you can't, right? The data has to persist somewhere. Data is what actually matters at the end of the day. And it matters to every single application that's going in the cloud. And so we find there's the default assumption of how storage works on-prem that doesn't exactly translate to cloud in every single case. Right?
Yep. I mean, object storage seems to be the go-to in the cloud, but in more traditional environments, as you know, and as our viewers probably know, we have NFS and just other technologies that aren't necessarily cloud ready.
Exactly.
If you could say.
Yeah, so NFS is a common protocol that applications use and the like. So the question is, how do I address the second order problems without slowing down the move to cloud, right? So that's where Elastifile comes in. As you look at public cloud options for file systems that are compatible with on-prem, there tends to be a lot of caveats and limitations, whether it's how much capacity I can scale up to, how much performance I can get, enterprise features people are accustomed to, like snapshots and backup technologies, things that are sort of taken for granted on-prem that are quite a bit different in cloud. So there's options out there, but they all tend to have some sort of a downside, whether it's performance, scalability, price, and the like. I think file system, in my experience in cloud, is kind of viewed as a luxury option. It's kind of high. It's a high cost approach, right? So what Elastifile has done is we've said, hey, we think we've developed a first order solution to the second order problem. And what we've seen with our customers that are moving in and going cloud first, they're, as they approach it and they run into the issue that says, hey, I can't get the scale, the performance, the compatibility that I need, we're able to come in a lot of these cases and sort of save the day. We have an interface that looks just like what they're used to on-prem, but we've designed to work seamlessly with the cloud in terms of scale, elasticity, consumption type models, and the like. So it takes the gap between traditional app and cloud and just eliminates it.
Excellent. Yeah, I've run into a lot of customers who want to see some kind of file system, some kind of traditional file system, and hearing about Elastifile has always been a very interesting conversation with our customers when that comes up. And obviously later we'll see a few demos on how this magic works, but it's just phenomenal to see that we're able to do typical standard file system type things in the cloud.
Yeah, we've seen the momentum pick up quite a bit. When we were here in June or July, we demonstrated some of our the file system in operation in Google, Kubernetes integration and the like.
Right.
And then we went to Cloud Next and presented there, and we've seen just a great uptick in interest and activity over the last 3 or 4 months.
Awesome.
There's probably 40, 50 new customers are using the product and trying it out and doing all sorts of things that we never imagined actually in cloud. Workloads like SAP, for example. Who would have thunk? It's, are looking for systems like this. So.
Nice.
So let's, what I'd like to do is dig into what we've done since then. We have a major release that we're bringing out, and like to show you what it actually looks like. As we've learned working with some of our early adopter customers, I have some of those on screen here. Some of the problems that we've addressed with them have really helped us figure out how to make the product even more cloud ready. To make it easier for people. eSilicon is a great example of that. You can see a testimonial video on our website and the Cloud Next session that we did with them. I think it's a great example of where a customer said, hey, we decided to go cloud, and we found that when we got there, we had challenges with storage. And Elastifile was able to come in with this cloud-ready scale-out system and just accelerated all the movement. Excellent. So they were able to do one of their first big tape-outs in cloud and solve a real problem for the company.
Good.
Okay. So what we've done, and we just announced over the last week, our version 3.0 of the Elastifile file system. And it's a huge release for us. We really took all the feedback and all the needs that we heard from our customers, and they said, we love the product, we love the feature set, we really need to optimize for performance and for cost. So we did a lot of work in this release to be able to deliver an enterprise class performance system that also meets the budgetary requirements that people have. There's always a balance and trade-off there. And so we designed this release to allow a customer to sort of dial in for themselves where the happy balance is between features and performance and the amount of budget that they have to solve for the problem. Awesome. And there's a series of technologies inside of here that contribute to that, all the while not sacrificing performance and high availability. There's some really interesting stuff we've done on the HA side to make sure we're still available. And then lastly, when you net it all out, what it does is it kind of broadens the tent, if you will, in terms of what type of customers can move into cloud, what kind of workloads they can move in with the least amount of friction possible.
That's good. I mean, this is definitely different than what we saw last time when you were here, or sounds different. We're going to actually show people, to those who remember. But yeah, it looks like you definitely have a solution to fill that gap, because as we mentioned earlier, we have people who are used to doing things one way on-prem. Cloud was built a different way. Filling in that gap of how do we run things similar to how we ran on-prem with file storage, something most people don't even think about when they're making that move. Having a solution to fix that will I think it's a game changer. I think it will definitely make the move to the cloud great for some of those enterprises that are, kind of on the fence. They're just like, well, I don't know how things are going to work, or how are we going to do this, or we've always done it this way. How does that work on the cloud? When you just have an answer and fill in those little gaps between on-prem and the cloud, it's making the adoption much cleaner.
Absolutely. Yeah, that's really the gap that we're looking to fill. People make the decision to move. No one really goes to cloud because of storage, right? It isn't the driver to go, but it's certainly a thing that blocks progress once they've made the decision. And nothing's more frustrating than that, than getting everyone on board or made the decision, and then we hit a blocker.
Right, yeah. I mean, it's one of those things, like you mentioned, you just don't think about. You have it, you use it every day, but when you're making that decision, it's in the back of your head, and you don't even realize it until, like, oh, how are we going to store our files?
Yeah, exactly. All right, well, let me show you a little bit about what's inside of here. The big deal for us, looking at the screen, we have our core file system, which is a software-defined scale-out file system. Point and click, you go to Google Marketplace, hit go, and the thing is launched in a few minutes and ready to start serving data. And that works it's a high-performance file system, so transactional I/O, lots of scale, both out and in. All that goodness, snapshots, data reduction techniques, all of that's there, even better in this release. We have a data management tool called Cloud Connect, which is all about taking data from any source location, usually on-prem, and checking that data into cloud, into object storage, and then making that available for processing work on the file system. And the new feature that we've added is called Clear Tier, and this is really bridging that final gap between a file system and cloud technology. So Clear Tier is the enabling technology. It allows us to take file system data and automatically move it back and forth into the object storage on cloud storage. So it gives you essentially an unlimited bucket for extending your namespace without any extra work. It's all automated. So I can get the best of a high-performance file system, but the massive scale of an object store without having to do any administrative work.
Awesome.
Okay. So that's core to the tech here. Clear Tier, there's kind of three areas we'd focus on. The first is it's really the enabling technology that allows us to do up to a 10x reduction in the cost of file storage in cloud. And I'll show you how that kind of works out. But the blending of file system on high performance storage like SSDs and the like, and object storage really enables us to go pretty far here. Cloud high availability is another big feature here. We've integrated tightly into the HA features in Google Cloud. Essentially, if Google is replicating the data, we don't have to. So we can maintain the same level of availability, but reduce the amount of storage we have to use to get there by 50% in a lot of cases. We've extended out the ability to do multi-zone support, so you can send a file system over many zones. So if there's an issue in a zone, we can continue on without any disruptions. And then lastly, we've extended the options for running the primary performance tier onto all the different types of storage available in Google Cloud Engine. So local SSD, persistent disk SSD, standard persistent disk, and then lots of configurations inside of there. So this is, between these three areas, allows the customer to say, this is the performance I need, this is the capacity I need, this is the level of availability, and so let me pick the right platform and roll. And by the way, in cloud, it's the most forgiving place in the world. If I made a mistake, it's not a 5-year problem. I can just go reverse it.
Exactly. Yeah, and this hits the big pieces of the cloud, costs. A lot of people go to the cloud because they want to save cost over the long term versus hosting stuff on-prem. And then the high availability. It's not always easy for an enterprise to spin up a data center here in EMEA, in APAC. Being able to use the cloud to do that, or use somebody else's data center network. Those are some of the big reasons a lot of people move to the cloud. It seems like Elastifile takes advantage of those.
Yeah, you can spin up the software in any region, anywhere in the world. There's no particular hardware requirements. Anywhere there's a Google data center, we can run. Awesome. And it's nearly instantaneous. You can spin up on the fly. So a little bit about the cost differential, showing here, what people are used to spending to get a file system running in cloud. More or less, it's the standard is about 30 cents per gigabyte per month. to run that. And as you start to add in these new features that we've brought, our most extreme performance tier is around that same range in cost, just under 30 cents. As you add compression to that, the cost per gigabyte effectively drops quite a bit. You switch to standard persistent disk, which is a cheaper medium. It gets even lower. Add compression to that, it gets even lower. And then you add in our clear tier feature, which automatically moves data back and forth into the object storage on cloud storage. And it drives down to around 3 cents per gigabyte per month effective cost, which is kind of unheard of for a fully functional enterprise class file system running in cloud. Okay?
Excellent. Saving money is always a good thing.
It's always good. It's
never going to hear me argue about
exactly. Exactly. So there's a series of capabilities that kind of compare and contrast against what's typically available in cloud versus what we're offering here. I've covered a lot of these, cost optimizations. We got much higher constraints in terms of performance and IOPS and bandwidth capabilities. As you need more, you just scale out. Enterprise grade services, the tiering to object, I'll demonstrate in just a minute. So anyway, the whole idea is I want to be able to offer to our customers an enterprise class experience in cloud without compromise. That's really what our driving mission is, okay? So, where we've seen usage, there's sort of a horizontal look at where this tends to fit for people, and then there's a vertical look at it. So horizontally, file systems are needed by just about everybody. They just come in different formats, whether it's an object file system, a POSIX file system, a shared file system. But anyone really that needs NFS for Linux applications and the like, this is a great fit for them. If you need sharing, and this is an excellent fit for you. This comes into play. We demonstrated last time with Kubernetes, sharing data between containers and the like. And then one that we found common across almost every one of our customers has been the desire to use preemptible VMs without the downsides of the preemptibles. Right? The preemptibles are great because they're high performance, they're low cost, but they're unreliable by design. Right? They preempt, they just reboot. Or actually they power off and new one gets instantiated. If your application isn't designed for that, it makes it really hard to work with in there. And so we bring a level of reliability to a preemptible VM that didn't exist otherwise. So those are, sort of generic use cases that anyone can sort of fit into. Where we found nice, congruence with the technology has been in several vertical industries. Media and entertainment for one, people making movies or doing visual effects, specifically rendering transcoding workloads. They're very data intensive, large data sets, they have tight timelines they need to meet, so performance really matters here. And the ability to instantiate these instances on the fly really helps. In life sciences, genomics, drug discovery, things like that, there's a lot of file system driven workloads. In manufacturing, we talked about eSilicon with EDA, and then finance. All these verticals tend to have a lot of applications that they've either been around for a long time, and whoever designed it isn't around anymore, or it's a ISV third-party application that the customer can't change, or they just want to spend their energy building new applications and they want to get the old one to work in cloud without any hitches. So anyway, there's lots more verticals where we found fit, but we're starting to see sort of consistency in these here.
Awesome. Yeah, and also just, for example, with machine learning too, those models have to live somewhere. So I could see any one of these people or these verticals using it. Just the way the world's changing, the way the technology's changing, we still need a lot of storage for things. Yeah,
in fact, if you go to Cloud Next from this summer, we did a joint presentation with Google on Kubeflow, where I've got TensorFlow integrated with Kubernetes, and we showed how Elastifile can make that kind of multi-cloud ready and really enhance the experience for machine learning as well. Okay. So I talked a little bit about preemptible VMs. I'm pretty excited about this use case. Bringing a shared file system underneath all the preemptible VMs means when a machine goes away, the data does not. Yet I can connect the data right into the local file system, so it looks like a local POSIX file system. I can read or write data really quickly, and preemptibles tend to be part of big compute farms where they need fast access to storage. So we can deliver that, but when the VM gets preempted within 12 to 24 hours, you can spin up a new machine, reconnect to where you just left off, and you're off and running. So we really solve for that problem and finding you know, a lot of advantages here for people. 80% savings in cost on compute, and then you know, we're bringing a 10x savings in file system storage. You bring that together, and it's sort of a match made in heaven.
And as long as my data's there when the VM comes back up, I'm happy. So I can save money yet keep my data.
Yeah, lots of opportunity for applications that use schedulers, queue managers, and things like that here.
Yeah.
And I'll show a little bit of this in just a minute in the demos. So why don't we check it out? You ready to see what this looks like?
I've been waiting for a while. Let's see what this is all about.
Okay. Well, the first thing I want to show is a little bit about this clear tier feature, the automated tiering. So let me switch over and give you a look at the interface. So this is an Elastifile interface that's running in Google Cloud right now. And so this looks like a typical storage interface. I got capacity and performance and the like. And if you know Elastifile, there's a new option down here called object tiers. And so what this is, I've preset this up to make the demo go fast, but we've made a connection to Google Cloud Storage here. And so what this means is the cluster, this one's running on persistent SSD on the primary storage tier. And then what this allows us to do is extend that capacity into object storage on a Google bucket. Okay. And so there's two settings right here, and we'll see these move here as the demo goes. What I can do is set a policy for the cluster that says, ideally, I would like so much percentage of my storage to live on the primary performance tier, and then so much to live on the object tier. And this sort of sets a target for the system as it's analyzing data and things move on. It says, I'm going to aim for this as my target. And so once I balance out there, it'll balance out cost and capacity sort of automatically. Right? And so there's two settings in the policy. How much do I want on either tier? We'll just set this to, maybe someone is really cost conscious and they want to say, I want to have maybe 10% of my data live on primary. And then the second policy says how long before a file is eligible to be cooled off into the object tier. And so maybe that's they're really aggressive and want to do that at 4 days. This would be like a cost optimized situation. So what's really cool about that is as the data moves back and forth between these tiers, that's all happening behind the scenes. The end user doesn't know and doesn't really need to know because all the data in the entire namespace is still accessible from the same location. I can mount through NFS. So if a file is moved from our performance tier onto object storage and you move into the command line, I'll just give you a quick look at that. So this system here is connected to that storage. There's a file system called clear tier right here. And so I'll take a look at that. There we go. Let's just make this bigger for the audience to see better. There we go. So there's a bunch of files inside of this directory. And those are living somewhere in the file system, whether they're on performance tier or object tier. It really doesn't matter because they're all going to show up. All the metadata is in the primary namespace and they just work. And so if I go back and look at the data container where this data is stored, you can see this one here called clear tier. Here you can see the majority of the data is living on the primary tier, and then some of the data is on the object side. And so if I go through and just speed up the process, I can do I can say, let's move the data automatically. So we'll just run a command which will accelerate the movement. We'll say move the data to object. And so this is going to cool the files off, meaning the data that lives on the primary tier is just going to cool this onto the object side. And so this will run for a minute or so. But what you'll see is we're a gigabyte of data here. As this goes forward, you'll see that the data starts to move. It's progressing back. So you see that number's right here. This number just got bigger on this side. So the data is already shifted. And eventually it'll drain the data off the primary tier. And again, this is happening automatically behind the scenes. And as that finishes up, you'll notice over here, if I look at the files, nothing changed. The namespace is the same. If I read a file and interact with it, it'll automatically move it from the object tier straight into the active space where the user is, and they can do it.
So this all looks very simple, very basic setup, and then I just use it. There's no additional knowledge that needs to be done. I don't need to be a programmer or a database engineer or anything like that to use it. It seems like it's the file system on my computer. It doesn't look any different than that.
That's the whole point, is to make it look just like I'm used to. There's nothing new to learn, and it just works, yet I can still get the cost optimizations without sacrificing performance. Okay.
Yeah, and it was very easy to set up as I was watching. So
yeah, and the setup is it's point and click. You just click the buttons, add your object here, and you're good to go. So let's see, that should be finished up there. There you go. So primary tier has no bytes on it, and all the data is now on the object side. And so if we go into one of these data containers, and again, a data container is essentially a file system for us. It's a single namespace. So we'll look at this one. This one's called Infinite Snapshots. And you can see there's data on either tier, the hot tier and the object tier. Another feature that Clear Tier enables is the ability to create what we call infinite snapshots. Right. And this is a really interesting feature, sort of unprecedented in the primary storage world, that we can take as many snapshots as we want of a file system and store them infinitely without an impact on performance or capacity. Snapshots are great, but typically they're stored on primary storage, and they take away from the space that you want to use for performance applications and the like. It's kind of a premium location to store my data. So what you can see here, we can either do manual snapshots. So I have 2 snapshots already taken on this one. I have one that lives on the local storage and one that's on the object here.
Okay.
There's also a remote option in here that we can use for replication to other clusters, but we'll focus on the local versus object. So creating a snapshot's really easy. I could do snapshot 3 manually, and I could either define a policy here to say after a certain amount of time, just move it off to object, and then delete it after a certain time, or I can just keep it as is. So you'll see that one's created. It's instantaneous. There it is. It's on the local storage. I can now get back to that snapshot. If I go back to my command line, I'll move into that directory. And there's my local file system. Image files is in there. I can see some data just to prove that it's real. There it is. And if I do, if I look at the .snapshot directory, which is hidden, I can also see those 2 snapshots sitting in there.
Okay.
And so if I go inside of there and say I look at snapshot 3, I can see all the files that were taken at that point in time. And this is a really nice feature. So an end user that's interacting with the file system can go back in time without ever picking up the phone to make a help desk call and say, hey, storage admin, can you go reconnect my data? Right. All of my snapshots are here. And not only are they in that directory, but you notice I have one that lives on object over here. So there's a new directory that we created. If I do .object instead of .snapshot, take a look at there. Snapshot 1 exists in this .object directory. And so you'll see there's the same files are inside of that directory. They're accessible forever. If I wanted to move manually the snapshot to the object here, I just hit the button. It'll work on it for a minute or so, and it's done. So this really helps people not only get easy access to old versions of data, but it's great for disaster recovery and even backup type scenarios. So essentially think about this like a built-in backup system. Right. The schedule allows me to say, every, say, 12 hours, take a snapshot, and after 24 hours, move it to the object here. And then after, say, I don't know, maybe let's call it 2 weeks, we'll call that 14 days, delete it. So I've got this rolling set of protection, and the data is off of my primary file system. It's stored forever in Google Cloud Storage. Can recover it whenever I want.
All right, looks like we just created a data retention policy in under a minute. So.
Done. With one finger, left hand is unbusy. So yeah, that's another big feature for us. So those are some of the base technologies. And what I'd like to do is show you what this looks like in action. So as an example, I mentioned some vertical use cases where we're seeing some traction. I'll focus in on media and entertainment. We've had a number of companies that are in this space. They're very active in cloud. They love preemptible VMs. They're massive consumers of compute. They'll generate load for tens of thousands of cores. Some of them are in the hundreds of thousands of cores. And as you can imagine, if you have that many cores to process, there's a lot of data that needs to feed in and get churned through and then spit out. So in the sort of media and entertainment workflows, we found as it goes left to right from creating the assets. This is recording videos and people editing movie clips and things like that. Once they get generated, there's a rendering process and a transcoding process that happen. Rendering when we're actually putting the videos together, and transcoding when we're making the videos ready for all the formats. I'm not an M&E expert, but we're seeing our customers mostly in these two areas find a lot of use for the product and enablement in Google Cloud. And so I want to show you a process that works with that, what it looks like, and in the demo is set up. We have an on-premises render farm, which is pretty typical for a visual effects company. They'll have a bunch of compute nodes and local storage and a queue management system to manage all the jobs as they go. And then we have essentially a render farm created essentially on demand in cloud. And what a lot of these companies are doing is they need to get the data, the raw data, into cloud to be rendered or transcoded. And so where Elastifile fits in is Cloud Connect is able to connect to existing local storage, whatever that might be, if it's on an Isilon or a NetApp or whatever.
Right.
We can take that data, we can pull it off, stage it in cloud, on cloud storage, and it's compressed and deduplicated. And then we're taking point-in-time copies. And just at the point when they're ready to do the work in cloud, ClearTier then comes in, can take that data, connect it to the file system, and make that available to the farm of preemptible VMs. And this can all happen managed by a queue manager, essentially on the fly.
Nice.
Okay. And then when they're done, you can tear all that down and put it back the way that it was. So my consumption in cloud is limited only to what I've actually done. And that's, again, the magic in cloud is thinking I can do things instantaneously and on the fly, and they don't have to live forever, right?
Exactly. Get rid of the machines when you no longer need them. No need to pay for them when they're not in use.
Right. So let's switch over. I'll try to manage it from here. So I've got a project running in Google Cloud Console. You can see these Blender servers. Blender is our rendering application. I've spun up 10 of these right here. And then there's an Elastifile system running behind the scenes, much like the picture showed you there. So if I kick this job off, I'll run this one here. So there's all right, so this is essentially our queue manager, right? So what just happened is we've pre-uploaded data into a bucket in cloud storage, and the visual effects engineer said, okay, I'm ready to render this data. Queue manager, go do your work. So what just happened is it said, okay, I'm going to grab your data and I'm going to check it out and I'm going to put it in the local file system. Now, I'm going to accelerate things. What it's going to do, just for sake of the demo to show that this actually works, is it's going to cool that data off. So it's going to take the data that's in the primary file system, which I can show you over here, this one called Blender. So we're taking the data, we just moved into here, and you'll see the data shifting over to the object side as it finishes up this little step here. See that number's going down and this one's going up. So we're bleeding the data back into the object storage. And you might do this maybe if I'm not ready to run it yet, or I want to keep my costs as low as possible, for a variety of reasons. But as that kind of cools off, you'll see it essentially go down to 0, and then it's waiting for us to go. So what's going to happen now is we said, all right, that data's out there, go render it. So each of these servers is now connecting to a shared file system, the same exact data container, and it's going to connect to those, and they're going to start rendering their work. So they're going to churn through all these assets and create these, a beautiful scene at the end and make it all happen. So these are pretty beefy machines. Each of them has 64 cores, and they'll process all this data and spit out the results in the end. So while that's going, we can take a look at and see some of them in action. Let me pop over here. We could just exit out of this one, and we'll connect to one of those servers as it runs. Compute, and we'll connect to Blender server, call it 1. Okay, so this server is working. We'll switch over to the admin view. There we go. So let's see if what's going on. There we go. So that's the rendering job happening in this behind the scenes. You'll see that it's processing all these tiles and doing all this work, and it'll run for 4 or 5 minutes to finish up all of its work. If we take a look here, let me exit out of that, and we'll see how busy the server is. You can see that the CPUs are pegged. There's 64 CPUs there at 100%. So it's really doing a lot of work right now and making that happen. So here's what I need you to do, Jay.
Right.
You are going to be the preemptible logic guy, since you work for Google, to accelerate what might happen with the customer. At any point in time, a preemptible VM will disappear. You have about 30 seconds warning.
Yeah.
So why don't you pick one of these servers and we'll go kill it live and see what happens.
Let's go with 6.
All right, 6 it is. 6, you've met your demise, and be deleted here. So this is exactly what happens in production. You'll get a warning from Google that says, hey, this machine's going to be preempted. You have 30 seconds to exit the premises, and it's going away. So this will take about a minute to kill itself. And what will happen is we'll take a look here. So now this system, this is essentially like our queue manager that's monitoring the status of all of these systems. So it's watching for a preempt that has occurred, and what it's going to do is react to that. Let's see what happens when it goes. But you can imagine this is a similar pattern that we see again in all these different industries. The queue managers come in different flavors, schedulers, whether it's HPC or specific ones for media, EDA and the like. They're all very similar in their capabilities, and they're all really adapting quickly into cloud. As we've worked with a lot of these guys, they've been figuring out how to work with the cloud APIs and adapt to it. So there you go. So we just detected that number 6 was missing because you killed it.
Yep,
but we said we won't be stopped, so we'll create a new server called Blender number 6. And what that's going to do, we'll refresh the cloud console. And this one that's spinning and going away, as that refreshes after a minute.
Might take a minute. Yeah, there it goes. It's back.
There's a brand new one that's up and running. And that's going to send another job, start the rendering again, and I'm off and running, right?
Awesome.
And if you can imagine this happening with 100 servers, 1,000 servers, tens of thousands of servers, that kind of churn is happening all the time. So we're now able to keep the workloads active, busy, and so these customers can meet these tight time frames that they're leveraging cloud for.
Nice. Well, preemptible servers are nothing to worry about anymore. So looks
there you go. So that's a little live look at what we're doing here. Again, the preemptibles, I think, is the big story with that workload. And that's really kind of the summary of what we're doing with 3.0 Elastifile.
Excellent. Well, stay tuned for live Q&A. We will be back in about a minute. Welcome back. Let's go to some questions, how about? Why did you decide to integrate object tiering into your solution?
Yeah, that's a great question. I would say there's two answers to the question. There's a technical answer and then there's a business answer. I'll start with the business one first. It just makes sense. Object storage is massive. It's really cost effective. It's the primary storage medium in cloud, and you really got to integrate with it in order to be relevant in cloud. And it's kind of becoming it's the data of record location for most applications in cloud. That being said, there's a technical problem with that. Object storage isn't great for all workloads. It's not really transaction oriented in the sense if I have a workload that needs to do a lot of small reads and writes really quickly, object probably isn't the place for you. Or if you're adapted an application that needs protocols like NFS and SMB, there can be some performance lags as it goes back and forth into there. So we decided to integrate, to capture the cost and availability and scale, features that come out of object, and then enhance it with, some of the file system capabilities that we bring to the table.
Awesome.
Yeah.
Can I support Windows file systems with this?
Yeah, that's another great question. The current version of our product it's NFS based, which typically makes you think about Linux type applications, although Windows does support NFS. And we've had customers successfully use that. Typically, the primary means to access data through Windows in a shared file system is the SMB protocol.
Right.
And so we're actually working on a version of the SMB protocol that we'll release in the not too distant future, which will expand the reach even more for Windows-based applications in cloud.
All right, well, stay tuned for that one. And final question, can I use this on Google Cloud Platform today, and how would I get started?
That's a great question, and maybe we can switch over to the next step slide as we talk about this one. So yes, absolutely, you can use this on Cloud Platform today. It's very easy. If you follow the link on the bottom of the screen, just go to Cloud Marketplace or just search for Elastifile in Google Cloud on a Google search engine. It'll bring you right there. Click the button, connect it to one of your projects in Google, and you're launched in a few minutes. The other option that we just released, and we're excited about this as well, is Quick Labs. So Quick Labs is a training capability inside of Google. So if you go into Quick Labs, follow the link here, google.quicklabs.com, search for Elastifile, and you can launch a Quick Lab that will take you through the install process into a project. You can play with it. It's a live system running in cloud, and you can try some things out on your own. And if you ever run into trouble, just give us a call, support.elastifile.com, and there's knowledge base articles and access to our engineers, and we're happy to help.
Awesome. Well, thank you very much for coming out and telling everybody about the benefits of Elastifile, improving their storage on Google Cloud. Stay tuned for the next session, Intelligent Content Collaboration with Google Drive. Thank you.